what arenas are people saying they need more of? Is it database processing? Is it energy, physical space? Like, what are some of the things people are wanting?
All of the above is the easiest answer, but I would say at high level, you're right. Everybody wants more energy density, meaning that you want more intelligence or more connectivity, but you cannot draw too many specific projects if you stay at that high level. Then you come down one level and say that, okay, you want more energy efficiency. That means you need a better battery, but also you need a better battery management. How do I do that in the most effective way? So all of these pieces have two angles. One angle is incremental innovation, how to make things slightly better by doing more smart things every day. And the other angle is disruptive innovation, means that how about we do it in a different way? How about we have a new material? How about we have a new approach to this thing to make things 2x, 3x, 5x better?
Welcome, everybody, to another episode of IT Visionaries. And today I have a special guest. His name is Dr. Ahmad Bahai, and he's the CTO and Director of Research at Texas Instruments. The Director of Research part is a group within there called Kilby Labs. We're going to talk about that in just a moment. Now, for a lot of us, and if you're in your 40s like me, you know of Texas Instruments for their famous calculator, the TI-82. I know that there's newer models now, but that's what we used. But they're way more than calculators. In fact, calculators, I would say, are just a fraction of the things that they do. And so I'm pumped. Ahmad, welcome to the show.
Thank you. Good to be with you, Albert.
Hey, listen, let's start right there because Texas Instruments is actually a huge company developing technology that I think every single person listening to the show is probably using a product made by TI or a component made by TI. And it's not the calculators that they're using. And so let's start there. What is Texas Instruments and what are just some of the things? Because I know you can't name your website. If you name your website, we'll be here for an hour. What are just some of the things you guys do?
Yeah, thanks, Albert. Texas Instruments is a leading semiconductor company in analog and embedded processing. And as you pointed out, pretty much there is a very high likelihood that all the electronic devices that you have around you has some components of TI, from your phone and computer to your car and the robots to satellites and medical instrumentations. All of them have most likely a component there because we offer a very wide range of products and technologies across the board in many markets and many end applications. As you know, analog and embedded processing is a critical part of almost every system you can imagine in electronics, because every electronic system requires power management. Most electronic systems have some way of processors in it. They have some analog and mixed signal that ties the real world to digital world. And all of that are fueled by semiconductor technology. And TI, as you pointed out, has been around for many decades. In fact, pre-existed semiconductor invention in Bell Labs. And we have been in technology. And as you said, we have presence across the board.
There you go. And for anyone who wants to see, they don't even, we joke internally with our team members because a lot of people, of course, know the calculator because that's like kind of the first introduction. I think a lot of people have to TI, when they're like 16, 17 years old. But if anyone wants to take a look at their website, I mean, the applications for the components they make go as far and wide as just, I just mentioned, automotive, communications equipment, enterprise systems, industrial, personal electronics, all this stuff, technologies, edge AI. I mean, like the list goes on and on inside of the website. For yourself, what does it mean to be the CTO of a company that has this many product lines like this? I mean, I don't like I think our audience wants to know, like, what is it that you do? Because it's hard to imagine you understand all of these things.
Yeah, actually, it's an interesting challenge that, you need to deal with so many different technologies across the board. Many other companies are very focused on one area, but we have a very diverse set of technologies, a diverse set of applications that we are addressing. And a CTO's job is really to look at opportunities for strategic and disruptive innovations that can happen in some of these key areas that we are working on. And some of these strategic initiatives are foundational to many products. For example, if you have a process technology that can be applied to many different types of the products and technologies across the board and applications, that can help us to stay ahead of the competition and create new business opportunities for Texas Instruments. So part of the CTO's job is really to look at what's going on in the industry, what's going on in the R&D, and how to connect the dots so that we can bring these foundational technologies to the level that our product lines, our business units can take advantage of that and offer the most compelling leading products and technologies to enable your next phone or next autonomous driving or car or intelligence in the car or all the features that you have in the cars or in the industry, I mean, ranging from robotics to industrial control and factory automation and so on, to healthcare and so on. So all of these can benefit from innovations that are so fundamental and foundational to semiconductor industry.
Yeah. And so this is where I'm very curious about your your daily role, because I'm imagining, and this is what I'm imagining, so please correct me if I'm wrong. The different product lines have leads, and these leads are developing products inside of their product line, and they might encounter a problem or maybe an opportunity or solution. So they probably bring it to you and say, hey, Ahmad, I found this, whether it's a, network solution, whether it's a material supplier, whatever it is. And then I know companies say they don't want to be in silos, but I'm imagining that's really hard. It's an easy thing to say, really hard to do, because if I'm working on like the medical devices line, I don't know how much I'm talking to the other lines of business at TI, right? And so I'm imagining you're meeting and like looking for these opportunities, like, hey, can we do that? Could that work here? Is that how you would describe like a layman's term of what you're doing on a daily basis?
It's part of it. Actually, the great ideas or disruptive opportunities in technology can come from many different sources. I mean, it could be inspired by talking to your customers when they talk about their fundamental problems that they cannot fix. Okay, the next robot or the next medical system or next one requires such and such. So you kind of listen to them and understand, okay, what is the roadblock for the next generation of a new product? So sometimes the CTO of a customer can inspire a new idea in your head. Sometimes your engineering team can kind of come across something that, okay, here is a fundamental problem. It's not just an engineering on a daily basis, but it requires a new material, a new process technology, a new approaches. Or sometimes comes from engaging with R&D centers, being universities or major R&D centers that, okay, here's an idea. And then my job or a CTO's job would be how to connect these dots, because great ideas are out there, but not every great idea is consistent or necessarily applicable to what you're doing. So you need to understand what you're good at, what is missing for your portfolio, what are the key problems customers are losing sleep over, and connecting these dots and offering an opportunity for innovation. And again, this innovation, it cannot be nurtured in a bubble. It has to be engaged with people who are going to offer the end product. It has to engage with customers who are going to use the end product. It has to be with IP houses that can really help you expedite this development of new technology. So I think CTO's job is really connecting the dots across the board.
It's funny you mentioned that about like the connection and how it can integrate with existing technologies, process, people, whatever the case may be. And we've heard other CTOs talk about this in the past, where they talked about, hey, data flows or your products, whether it's products, data flows, everything is all about the chain of strength or the weakest link, because eventually data, products, technology finds the weakest link. And I'm curious, because you have customers in all these different industries asking you to develop solutions for their problems. I'm curious, what kind of problems are people seeing right now? Where would you say like is the most prevalent? And I want to throw out something. So it's like, strike away talent. I think everyone's in a battle for talent. A strike away budget. Of course, everyone wants something at a lower price. And then strike away time, right? Time is always a constraint. People always have like, hey, I need this by next quarter. But what arenas are people saying they need more of the most, minus talent, budget, and times? Is it storage? Is it the compute? Is it data transfer speeds need to be improved? Is it database processing? Is it energy, the amount of energy something takes? Physical space? Like, what are some of the things people are wanting? And please don't say all of the above. Because I think the answer is all the above. But
yeah. No, actually, it really, I mean, yeah, all of the above is the easiest answer. But I would say the more accurate answer, if I want to articulate a little bit more on that one, is that at high level, you're right. Everybody wants more energy density, meaning that you want your car, electric car, running more on on single charge, or your phone on a single charge, or you want more intelligence or more connectivity. So connectivity, intelligence, energy efficiency, these are the common themes, regardless if you're talking about your phone or your car or your robot. I mean, they're all kind of asking for that. But the next level, I mean, you cannot draw too many specific projects if you stay at that high level. Then you come down one level and say that, okay, what does it mean? I mean, you want more energy efficiency. That means, let's pick energy as an example. Because a big, I mean, you're a leader in power management in the world, and you need to have more energy in a smaller form factor. What does that mean? You need a better battery, but also you need a better battery management, how to charge and discharge, because the way that you charge and discharge make a huge difference in terms of the longevity of the battery and also efficiency of the power management. Then how to use that charge more efficiently. So every step of this chain, as you dissect it and get to the next level, requires a fundamental technology disruption. For example, if you think about, okay, how do we know what the state of the charge my battery is and how do I deal with it? How much energy should I draw or put into the battery? How do I do that in a most effective way? So all of these pieces have two angles. One angle is incremental innovation, meaning that how to make things slightly better by doing more smart things every day. And the other angle is disruptive innovation, means that how about we do it in a different way? How about we have a new material? How about we have a new approach to this thing to make things 2x, 3x, 5x better? So both of them are important because to stay competitive, you have to continuously improve your technology on an incremental way, and it takes a lot of innovation. But also you need to look at some step functions that, okay, how about brand new ways of doing power management in this and that application with new materials? And that is the target 5x or 10x. And obviously, when you're talking about that kind of disruptive innovation, there is a risk attached to that because it may not work. That's where it comes the skill of risk and reward management to see that, okay, how do we de-risk these technologies without burning the budget or disrupting our product line activity? So it's kind of like this skill of, how to manage the risk or de-risk these advanced technologies that can solve a big problem for customer. We can extend the same concept into connectivity. Okay, I want to be connected all the time. Okay, what does that mean? How much data, how much energy are you willing to use for that? How much, the universality, do you need every data everywhere? Then there's a cost attached. So all of these, you need to take it into the picture and say, okay, what are the opportunities for changing the concept of connectivity in a fundamental way with a new technology? So that's how I would say at the high level, like you said, is all of the above, but at the next level, there are specific details from device, material, circuits, software, hardware, algorithm, and all of these that have opportunities for innovation.
Imagine a world where your data flows like electricity, unseen, yet powering everything you do. A world where high availability, low latency, and disaster recovery are not just expectations, but realities. Welcome to the future, powered by Zayo's network. Zayo has meticulously designed North America's largest independent fiber network, a network that isn't just vast, but strategically planned, connecting the places that matter most to you. Thousands of data centers, cloud on-ramps, towers, and critical points of presence. Cross-continental routes unique to Zayo offer connections that you just can't find anywhere else. Zayo provides routing diversity that ensures your operations never skip a beat, and ultra-low latency for when microseconds matter. In a world that never stops, Zayo is the network underneath it all, helping the most innovative and forward-thinking companies grow. Because Zayo doesn't just connect places, they connect possibilities. Discover the power of Zayo's network today. Visit www.zayo.com/network. Yeah. And so I'm sure everyone's pushing. I had a feeling everyone's pushing on every customer probably has an arena here that they're pushing, right? Hey, I need it to move data faster. I need to store more data here locally. Part of the different laws, like whether it's Moore's law, or I saw this new thing that talked about how solar energy is getting 10% more efficient, like a yearly basis. And as well as the cost of solar is decreasing by 10% every single year. And they were talking about, are we in a reasonable time frame to see a future where you're talking about literally endless energy just from the sun? And it's like, is that even possible? And so I know these companies are pushing you because they want to move more data. They want to move it with less energy. They want every one of their applications to run longer. When you are overseeing a company like Texas Instruments, where a lot of your products are physical, and like you mentioned, you can do software updates. How do you think about, or how do you balance, like, whether we will address the solution with software or we will address the solution with hardware? Because if you address it with hardware, like you mentioned, new materials, of course, that means old product lines don't get the benefit of that. Like if I've already installed a certain chip or semiconductor in my components, and you come up with a new material, that might be great, but like, what about all my customers who have already received that item? How do you go about balancing? Or do you always pushing them simultaneously, like independent of each other? Like, hey, we're not concerned. Like the materials team, you guys have to keep developing the best materials. Software team, you got to keep developing the best software. We just always have to be pushing both arenas forward. Is that how do you approach that?
I mean, regardless of hardware or software, they're all enabled by semiconductor. That's the beauty of it. Semiconductor is so foundational that, everything you talked about from solar. I mean, we have I call it the free largest fusion reactor in the world, that is sun. That really, capturing so much energy by doing a more intelligent way of capturing the energy. Well, that is based on semiconductor. The data transfer you talked about, that is enabled by semiconductor. Processing data or gathering data, sensing data, all of them are semiconductor. So semiconductor technology is so foundational and so pervasive that almost everything you talk about or touch, there is most likely some level of electronics and semiconductor. My favorite example is that the doorbell used to be just a button with two metals contacting each other and ringing the door. Now you have the more advanced cameras and Wi-Fi and radar and connectivities and all kind of things.
Sensors to start recording, like it's crazy.
Recording and reporting who is walking there, what. So you can imagine how things are getting more intelligent, more connected, and more useful, at the same time affordable. And that's the amazing thing about semiconductor. Yeah. Semiconductor technology is one of the most, if not the most advanced technology invented in humans' history, yet it's still affordable because we know how to make it more efficient in terms of production and throughputs and yield and the entire ecosystem. So that's why we believe that semiconductor is going to be very pervasive and grows, as you can see. I mean, look at your car, how much gadgets you have in your pocket, how many things you're carrying.
Yeah.
So now, the trend between hardware and software, it really depends on the kind of applications. Many applications have some embedded software that doesn't need to be upgraded because it's so specific to that device. Some need to be updated. Some needs to be updated offline. Some need to be updated real time. And there are variations of that. But obviously, these trade-offs are very specific to applications.
I was going to say, it's kind of amazing that power management can be updated via software. Like some people's phones, after an update, it gets more efficient. Like it's kind of weird to think that because normally in the past, like you said, the battery is just a game of physics, right? It's got electrons, it's got a charge, it's got anodes, diodes, like it's pulling electrons out and eventually it can't pull anymore. But like you're saying, using software, you can change it.
Absolutely. I mean, the intelligence and connectivity and affordability are very important because the way that you put charges in or pull charges out can have a huge impact on the life of the battery, on the efficiency of the power management. I mean, we are getting to a point that we need more of all the above that you mentioned. And it can only happen by having more innovative approaches. We cannot have just a kind of traditional approach. We need to have more intelligence. We need to have more um, uh, understanding of the system level issues and how the trade-offs across different elements of system work. And sometimes it's just a matter of partitioning. Sometimes it's a new device, sometimes a new material, sometimes it's a new software and new machine learning algorithms. All of them can come to the picture. So those days of having just every individual perfecting their own piece requires to be enhanced to kind of collectively optimizing the system at subsystem level or at system level to make it competitive.
Is that now very common? Because like imagine I am, and I'm just going to look at over my desk. I got a computer, right? So like for example, I might have TI components in my computer. You might figure out a new way to better manage the energy or data transfer of my chips and semiconductor components inside the motherboard that I have with my customer. How often do you go? Like if you make a discovery, do you go to the supplier or the maker and be like, hey, listen, this is the new way. If you implement this in your next update, your PCs or your computers that you ship are going to improve by 20%, whatever the number is. But like, is that a common thing? Like, is TI constantly finding breakthroughs, going to customers and be like, hey, listen, this is a way we've discovered to make the semiconductor perform better?
Yeah, I mean, these days, the engagement with suppliers and customers are a lot tighter than before. So engagements through the analysis of what the system requirements are and how it translates to components is more and more important. And that's where we see a lot of success opportunities. Of course, there are parts that are really what we call it catalog part, and they are parts that you use it in different environment. There are parts that you engage with customers to define it in a way that we can solve some major problems when it comes to, for example, power management, energy efficiency, and so on. So we can see that interaction is becoming more and more critical, and it's happening more often.
Yeah. For yourself, what are some of the things that you, I guess, get most excited by or most fired up? Like seeing, you mentioned before, like for example, right, Moore's law, right? The amount of transistors will double, but the cost will stay the same every year or whatever. I forget the exact rule. You mentioned it's probably accelerating faster than Moore's law now. I'm curious, where or what spaces are you seeing maybe the most innovation in, or are you most excited about seeing some of these applications that some of the research teams are talking about come to life?
Yeah, actually, I think one of the advantages of being a CTO of a company like Texas Instruments with such a diverse technology portfolio is that you can be excited about a lot of stuff. So, so it's a wide range of stuff that I think it can change the future of electronics and all the many devices around us. For example, on power management, I'm very excited about these new materials that are coming up. So you can offer much higher power efficiency in a smaller volume, a smaller form factor. So that means you can drive a lot of new applications, again, ranging from your phone to your car to the robots to the drone to many other applications. These technologies are very foundational. We spend a lot of time on that, and we think that we are at the point these are ready for deployment. It's called technology like gallium nitride, which is the fundamental technology for power management, higher efficiency, and higher power density power management. There are technologies that I think we are going to change the future of. I think these are all like in complementary to Moore's law, because Moore's law driving the digital part of it. I mean, by refining and making the transistors smaller and denser, but also these technologies that can, for example, offer a new way of the timing. And because as the data rate goes higher, you need more and more accurate timing. You almost need a GPS quality timing on every device, and how you can come up with these devices that can offer that quality of timing. So we have worked on some technologies that can really change the entire concept of timing on portable or devices. There is another set of technologies on intelligence at the edges, or edge
Yeah.
AI, they call it, how to put enough intelligence on the sensing nodes that really you can do some of the analytics locally and not taking too much power or bandwidth to send it to cloud necessarily. We see a lot of interesting technologies coming from TI on that front. Also, a wide range of applications on connectivity. For example, how to improve the efficiency of connectivity and we always ask for more bandwidth. As we are doing this interview, we want a better quality of the video. We want kind of smoother technologies, and that means bandwidth. And everybody wants that. So, as you know, we are sharing the airwaves, so we are gonna be limiting each other's access to the bandwidth. That's where we need more efficiency and more wider band technologies, and that is another range of technologies that we are working on, and many others. So you can see that these technologies are, in addition to our daily improvement of our products, we see that they are game changers for the next generation of electronics and intelligence and connectivity and power management across the board.
Yeah. And when you were talking about, because we're, of course, doing this podcast over software that enables you to see me to see you, and so on, broadcasting our sound back and forth. Everything that we talk about has a physical constraint, right? So like the other physical constraint of bandwidth, of course, is the lines in the ground. I think a lot of people often forget that the internet's just a bunch of lines in the ground, right? And yeah, we have wireless signal towers that come out of the ground and they give you the illusion of wireless, but guess what? Your wireless internet terminal is a physical line dug into your ground, or it can be a Starlink satellite if they bounce it enough. But the idea, there is a physical component, right? The lines are in the ground, all right? And so how you mentioned the components at the edge that can process the data, bringing more compute to the edge. And I think about like one of the big, hairy, audacious goals of, I would say, the world is autonomous driving, right? And just to think about how much real-time processing compute must occur, because no one wants to drive an autonomous car that has to talk to a cloud, maybe hundreds of miles away, and wait milliseconds to know that it should brake or it should stop or whatever it's supposed to do. We want that in sub nanosecond. Like we want that instantaneously. When you think of the flywheel of demand, and I'm going to use my phone as a great example, because as you create more processing power, the software developers create more data heavy applications that require all the processing power, right? So I think of like how far a cell phone has come, where now literally my kids are streaming high definition 1080p games that are interconnected. They're gaming with other people live in real time. And so there's always going to be like I need more, because everyone builds, they kind of max out, right? People are always going to max out your chips. They're going to max out the power capacity. And so when you think about developing in the speed at which people want things, how do you deliver on that side as a company? Because I think probably every year, it feels like every year your customers probably want like chip upgrades or semiconductor upgrades. Like no one's going to want to wait 2 years, right? They probably wanted it yesterday, right? Like probably people calling you every day, like, "Hey, is it faster yet?"
Yeah, that's a good point, Albert. I think the way the technology works and the demand for these new applications, ranging from phone to everything else, from industrial and automotive, it keeps us going. I mean, this treadmill of innovation keeps going, and it raises the bar. People are now even very impatient when they push the button, want things happen right away. I mean, maybe 5-10 years ago, we had the patience of, waiting until the picture comes up. We wanted now instantaneously action and more bandwidth and better quality and higher energy efficiency. So all of the above. And as you raise the bar, people always want the next step. And what is happening, which is kind of interesting challenge for all of us, the way that data and data usage is growing is outpacing the Moore's law or any other paces of hardware innovation. So as we are making things better and faster, we always need to look into what is the next big disruptive innovation so that we can keep up with demand, because otherwise the gap is going to widen. I mean, you need more and more data. Like you said, there is so many fibers on the ground or under the ocean. There is so much bandwidth in the air, and there is so much energy that you can consume in different environments. And you need everything at the right point, right away, without any delay. And all of these requires more and more innovation. I mean, as you pointed out, I mean, you cannot have a car or a medical device only rely on cloud. What if the connection is not there? Or what if something happens? You cannot risk the patient or you cannot risk the driver.
Yeah.
So we need to have a lot of intelligence built in, but that intelligence requires a lot of other peripherals. We talked about power management, but also it requires connectivity to different sensors around the car, from the radar in front of you to the ultrasound around the car and all the cameras and everything. How to make those faster, how to make them higher resolution, how to deal with background noises. I mean, all of these keeps pushing. So it's really what I call it the ripple effect. As you demand more capabilities, it ripples through the entire system, from your processor to your interface to your sensor to your power management to your data collection. Everything needs to be upgraded. So we need to continuously drive that. And because of the exponential growth of data, we think that the gap is widening between what in the future a lot of these hardwares can support versus what is the demand. And that's where we need disruptive innovation. And that's the main job of a CTO, I think, in this company.
Well, I mean, it sounds like this is where, like, kind of the original question when I posed at the front is like, where is it breaking down first? And it's like the ability to manage the data pools now is just getting to the point where it's like it's physically not, we're not there yet, right? Like you mentioned, for your teams, when you're pushing, like because TI is going to continue to push, the semiconductor industry is going to continue to push. There's not a semiconductor, you're in a field unlike, you're not like a food company. You can't be like Tabasco sauce where you're not going to change the formula for 50 years. You're going to have every year. Do you feel like there's a pressure? Do you feel like your team members tell you like, hey, I'm on, like, you can't keep asking me to make this faster. Like, I don't know how to make this faster.
Yep, absolutely. And again, the dynamics of these markets changes. For example, consumer products have much faster turnaround time. You change your consumer devices more frequently. On the automotive, the cycles are different. On industrial is a longer. But yeah, you're right. I mean, every corner of the market demands for higher performance, an affordable cost, better energy efficiency, all of the above. And that makes it exciting because we think that semiconductor technology for last many decades have proven that can solve some of the problems that some of the physicists believed it was impossible. They thought they are getting to the limits of physics, and engineers proved that there is still more room. And we think that this chain of innovation even needs to continue even at the faster pace.
Imagine a world where your data flows like electricity, unseen, yet powering everything you do. A world where high availability, low latency, and disaster recovery are not just expectations, but realities. Welcome to the future, powered by Zayo's network. Zayo has meticulously designed North America's largest independent fiber network, a network that isn't just vast, but strategically planned, connecting the places that matter most to you. Thousands of data centers, cloud on-ramps, towers, and critical points of presence. Cross-continental routes unique to Zayo offer connections that you just can't find anywhere else. Zayo provides routing diversity that ensures your operations never skip a beat, and ultra-low latency for when microseconds matter. In a world that never stops, Zayo is the network underneath it all, helping the most innovative and forward-thinking companies grow. Because Zayo doesn't just connect places, they connect possibilities. Discover the power of Zayo's network today. Visit www.zayo.com/network. Yeah. How about for your teams? Because this is one of the things that everyone that comes on our show knows that they need, like, talent is one of the big, like, we said talent, budget, and time. It's like the three major things that everyone needs more of, but you cannot make, right? You can't make it yourself. You have to obtain it somehow other way. And if you get enough good talent, you create more time and so for yourself, how do you go about recruiting the people? What type of person is best suited for working at TI? Because this is one of the things where, everybody wants more talent. Like no one's like, I need less good people. Like, no. Everyone needs more good people.
Absolutely. I mean, depending on which, I mean, TI is a huge company. We have manufacturing, we have design, we have R&D labs, we have sales, and we have fulfillment. And we need talents across the board. We need people who are excited about technology, excited about to be in a technology driven company, and they are excited about opportunities to change the world and expand the business, and exposure to a wide range of products, wide range of applications, wide range of skill sets. Very few companies, Albert, have this whole chain of having their own factories. As you know, a lot of companies in semiconductor are fabless. They build their chips elsewhere in the foundry. We have our own manufacturing, we have our own design, we have our own sales and entire fulfillment and everything in one company. And that gives a lot of people an opportunity to get exposure to the wide range of opportunities across the board, wide range of opportunities for being creative. And in our R&D center in Kilby Labs, we want to make sure we work with almost every division, getting best talents. We work with many top universities. We target top talents in the areas that we wanted to spend time and money on. And we work with them in a long-term relationship. So it's not like just going to recruiting day only. It's just, engaging with them during their research, making sure that they understand what kind of interesting problems we are trying to address, and get them excited and keep them excited, and making sure that we have a very clear roadmap of how these ideas and innovations translate to business opportunity. Because the big difference between innovation and invention is that innovation is about getting the greatest ideas and converting them to greatest business opportunities, whereas invention is about just coming up with ideas. So I think our goal is, I kind of say that I want to summarize it. Innovation is about taking ideas to the money. Invention is about taking money to the idea. So that's a different kind of format. And that's why this kind of passion, this kind of talent needs to be recruited on a long-term basis and with the right pipeline of engagement with the right people and right institution and right universities.
Now, for yourself, Kilby sounds pretty cool, because I was thinking to myself, as you were talking, it felt like almost like a Project X kind of lab. What happens there? Does TI come with hey, we want to solve in these arenas and just let people try to figure things out? Does it come with more of an objective base? Because you mentioned it's innovation, it's not invention. You come out and set the objective, hey, we're looking for solutions in these arenas, and then just kind of fund researchers and kids that are really passionate about their space to try to solve these. How does it work?
Yeah, Kilby Labs was named after Jack Kilby, the Nobel laureate that they designed the first integrated circuit, and he worked in TI, and we kind of encourage people to be creative. But the key factor that we wanted to make sure it happens in Kilby Labs is we start with problems, not solutions. That's the big difference between Kilby Labs and a lot of other research labs, because smart people always have a solution, looking for a problem. The challenge is that start from a problem that people really care about and it's very difficult to solve. And where does that problem definition come from? I think that's the most critical part of this whole innovation process. That's where we talk to customers, R&D labs, and understand, okay, what are the problems that they really suffering for their next autonomous system, next whatever consumer product or industrial or medical, and so on and so forth. And once you understand the problem, these big problems that they have for their next big step forward, we try to translate those problems to technologies that can address that. And obviously, since problems are very disruptive, solutions are also risky. That's where the risk management comes to the picture. How to de-risk technologies without burning too much money on that one. And that's why you need to have these phases that, okay, you put a small team, go after this technology, and if there is a promise, then you expand. So you manage risk and reward almost on a monthly basis to make sure that, or quarterly basis to make sure that you have checkpoints, but you don't get the stuck with every road bump. You have the persistence, perseverance, passion, excitement, but also checkpoints. So a right combination of these, I think, is a very delicate balance, because on one hand, you may discourage innovators. On the other hand, you may just let them run forever without results. So that is where you need to have a lot of insight, hindsight, foresight, all of the above, to combine them and kind of make that call on a regular basis.
All right, so now I got to ask you a question based on that, because one of my favorite businessmen and inventors is James Dyson, and he was famous for working on his vacuum 3,127 prototypes before he figured it out. And so I'm imagining a team reporting to you. How do you evaluate hey, you mentioned benchmarks or milestones. Like, how do you evaluate, hey, we've reached this moment in time, you haven't quite, you're not quite at there, but I still want to fund the project. I want to continue the project because you look like you're making progress. How do you make that call? Because of course, Dyson, I once read an interview with him where he said, like, had he worked at an actual vacuum company, his project would have been killed. He would have never made it to prototype 100 or whatever it got to. But because he did it on his own, he had the runway to basically no one was going to stop him from keep trying. And so how do you balance that? Like, hey, this is not going to make financial sense. We got to stop the project. Or, hey, you're making progress. Let's keep going.
Yeah, I mean, that's a very good point. And there is no black and white answer. That the way we are doing it, I call it risk and resources are inversely proportional. And that's what I mean by that. If you think a project is making progress, but it's still too risky, you are not going to put a team of tens of people on it. You get the same small team, keep going. And once you build up that confidence that it's now less risky or has been de-risked enough, then you add more resources. So, and then at some point you say that, okay, now it's ready for prime time, or we spend enough time that, we need to think about other solutions, or we are pushing the limits of physics and it doesn't work. So I think the biggest challenge a research manager has, is how to balance the risk and resource equation. So it's still extremely risky, but extremely promising. Let's say I can make the energy efficiency 10x better.
Yeah.
Okay, the claim is big enough and it looks good because you have some potential ideas that can work. So I put maybe 2 top talents on that one, but just only 2. And then when you show me that, okay, wow, I have 3 solutions. Now it's 10 options, it's down to 3 solutions. Okay, add 2 more to the team. So we kind of constantly manage risk and resource in a way that we don't starve the project, but we don't let project die, suffocate under its own load of, too many people get involved. And I'm a big believer that, smaller teams can do a lot more innovative stuff than having a big team scratching their heads and see what's going on there. So those most passionate, most driven people with enough skills can drive the project in a small team. As you see the progress and as you see the options are narrowing down to some meaningful ways, then you add resources and you kind of give it more opportunity to grow. And at some point you need to have these checkpoints. But again, these checkpoints are very technical. It's not like, okay, now you burn too much money. Okay, so you can't afford to have more people on the project. Or it just doesn't work because you're talking about limits of physics. So you need to bring all these elements to the picture and make that call. And that's a very delicate call. And the reality is that you don't make the right call all the time. Innovation is not the right the straight line path.
It's not linear.
From
That's
A
right.
to B. I've been in many innovative institutes. I've been in Bell Labs. I've been in CTO of National. I had my own startup. I've hardly seen that day one, you say, okay, I want to go from A to B. And then you may end up on a point C, which is much more rewarding than B. And you just learn that. So it's like, it's not a formula that you can just put there and follow that. Otherwise, everybody would have been innovative. Every company would have been as innovative. It's just that kind of mix of risk and reward and insight and tying it to the end applications and looking at all the components of this and passion and excitement and talent. So all of these, you need to put it in a picture and keep staring at it and make the right call. So the answer is that there is no formula for that. And usually innovation is a zigzag line. You start from A,
That's right.
you end up with the wrong point, and you go around. I mean, there is so much you can foresee in the future unless you get to the trenches and make progress and say, oh, by the way, there is a better path. Let's go right rather than left. And you keep improving it. So innovation is a very exciting nonlinear process that is hard to formulate. As much as I love mathematics, I don't think there's a mathematical formula for that.
Listen, you can call it confirmation bias, but your story there just further cements my personal belief. It's just my personal belief that when people talk about AI disrupting everything and taking over all decision making, I say it's never going to happen because companies, this is what it was phrased to me. Companies are all a company is just a group of people making decisions. And then a lot of innovation is making decisions based on a little bit of data, but also a little bit of a hunch. A lot of innovative ideas come in the absence of supporting data, right? Maybe, or it's too small. And so if you were to hard program, like you suggested, if you were to hard program a metric or something like that in an AI model, it could easily kill things that, like you mentioned, A to B, but it actually goes to C. It would kill things on the way to A to B. It would never allow someone to find C. And so that's why when people say, oh, AIs can make all the decisions, I'm like, it's never going to happen. I just don't believe it because that's all we are, especially in your world, innovation. You're just making decisions, predicting the future based on a little bit of data of what you have today. And it's hard to say what's going to happen tomorrow. And I think your approach, like the way you were very honest about it, saying like it's a little bit of, you didn't quite say guts, but there's a little bit of guts and instinct in there in the decision making. Like, hey, let's continue this project.
Absolutely. I mean, look at all the big success stories. I mean, there has been always many no's, hundreds of no's for every yes.
Yeah.
And then if you want to listen to no's, you say, okay, it's not possible. And then say, okay, my intuition, my experience, whatever it is, it says, there is an opportunity there. And sometimes you're wrong. I mean, not always you're right, but that's where your intuition, you build up an experience. And that's why humans are different from machines. Humans rely on intuition with a small amount of data. Machine relies on massive amount of data without intuition to replicate intuition. And that's the question is how much it can replicate or not. So that's how we see that. I mean, that's the difference between LLM models and how humans learn language, right? Humans learn language from minimum. I mean, a baby learns from the basic words and build up on that, whereas large language starts from large language, right? So I think we have different approach to the problem. But my point is that innovation is about converting great ideas to great business opportunities. It's a process that requires a mix of skills, insight, intuition, and capability of taking the risk, but calculated risk, not just unlimited risk. Yeah.
There you go. If you were paying attention to what Ahmad just talked about, it is exactly what is happening in his industry, in all of our industries, with AI being at the forefront of every company. He just said it takes so much data just to get close to human intuition and instinct and things. That's what the beauty of the human brain. Like it is just so powerful. Like it literally takes billions upon billions upon billions of dollars of data, research, technology, processing speed, network, all that stuff, just to recognize a dog from a cat as fast as a human can.
and by the way, Albert, one thing that I want to add to that, the entire processing our brain is doing is less than 20 watts. Versus if you want to do the same thing with the most advanced machines, orders of magnitudes higher power consumption. So we burn a very little power to do all this massive intuition and kind of
The average man could do these calculations off 2,000 calories a day. Like listen, a data center
and not
uses
all of
more
it
energy.
goes to your brain. Not all of it goes to your brain.
Well, Ahmad, it was a lot of fun having you on the show. Listen, before you go, we have some simple questions because I got to ask, we always want to get to know our guests a little bit better. Look, you got a lot of books behind you. So what are the subjects of those books? I can't quite see the titles. Like what do you read back there?
Okay, I have a very diverse, a wide range of interests. I mean, I love multidisciplinary innovation because I am a big believer that disruptive innovations happens at the border of different disciplines.
Okay.
because once you learn a discipline, for example, if you are in semiconductor industry and learn physics of semiconductor, and then go and learn about biology, then you may cross-pollinate some ideas that, wow, things that we thought is just specific to semiconductor materials maybe is happening in a different way in a biological system. So I'm a big fan of multidisciplinary innovation. The great thing is that TI is a very multidisciplinary company. We are dealing with all kind of technology from semiconductor design and physics and process development, manufacturing, all the way to design of circuits and systems and solutions in analog and embedded processors. But also, I always look at these fringe fields that are quite exciting. For example, new materials, how new materials can change the world. Biochemistry, how can biochemistry or biology or synthetic biology, how these algorithms and AI and all these machine learnings can change the world. So this diversity of disciplines can bring a very new perspective. I mean, it's difficult because you need to be learning a lot of stuff, but the learning process is fun, no matter how experienced you are.
Listen, if you're out there listening and you not watching us on YouTube right now or not watching the social promos, this guy's got an absolute catalog of books behind him, and he's just revealed that most of them are about interdisciplinary, I would say educational works. So if you ever want to have a smart conversation, Ahmad is your guy. Hey, listen, I want to say thank you for joining us today on IT Visionaries. It was a lot of fun hearing about what you guys are trying to accomplish, the innovation and requirements the customers in the world are putting on TI to say, like, hey, make it faster, cheaper, nonstop, and more energy efficient. Listen, we as people get to benefit from the innovations that his team is making. If you're interested in being part of the semiconductor industry, check out the show notes below. Ahmad, it was awesome having you on IT Visionaries.
Thank you so much. It's fun talking to you, Albert.